Oh, sorry.
Yeah.
Uh, it's written to start the system, open the rack door. That makes sense to somebody? Hmm. I'm afraid to like break it if I press on stuff. Okay, so to not waste time, I suggest, can you connect to your Zoom link so that now I'm like sharing my Zoom, so then you can. I think I'm requesting the help of some IT person, but yeah, just in case. That's a bit strange, but yeah, that's a upside of having Zoom is we can use it. Wait, tell me when you're good and. I have viewed the IT. Okay, so it's written to start the system, open the rack door with my what key?
You don't have a key?
Oh,
Volume key? Are you a professor here?
yeah.
Then maybe you're a TA. You know.
I'll just check if the.
It's
Okay,
already
now
open,
it's
so
working.
if
Okay,
you
okay.
close it, it's going to.
Anyway, so next time I'll know I can try that.
Yeah. And please try to press help one time because we get alerts for every time you press
Oh,
help.
I
Okay.
wasn't sure the first time.
Okay.
Thank you. Thanks a lot. Okay, here it is. So today emission taxes. So emission taxes, one thing it's also, so it's in the literature, it's called Pigouvian. In honor of an economist that is called Pigou. Not sure of his first name. Yeah, so Pigouvian taxes or Pigouvian subsidies or any measure that affects prices are in the case of externalities are called Pigouvian. So Pigouvian taxes are, so it's taxing pollution so that we get less of it. That's his idea. And of course, that's very long time ago, maybe 100 years ago. So that's old literature. Economists have been arguing for this for a very, very long time. And now it's sort of, the idea is really starting to get traction at last. So what's the principle? Well, polluters can discharge any amount they like. So we're not deciding for them how much they have to discharge. Any of them, not even a quota at the industry level. We say whatever you decide, but for every unit, you're going to pay this tax per unit discharge. Yeah, so in a way, pollution is priced. So we have an incentive to release less of it. So we say that, yeah, it's by price, we mean the, the externality is internalized by so internalized meaning rather than something that they don't care about that they drop on the rest of society. Now we make them explicitly consider it in their decision. So this is the price that we have to pay as a society for every unit of pollution you emit. So now you're just going to take that into account when you decide how much to pollute. Yeah, so the emission taxes incentivize polluters to find the best way to reduce emissions. rather than having a central authority determine how it should be done by a standard. So again, we're not saying you should install this or that system. We're just saying however you want to do it, however much you want to emit, as long as you pay us, we're fine. Yeah, so what happens in practice is if the tax rate is above the marginal abatement cost, so it means that it's paying the tax is more expensive than abating the unit of emission, then the polluter should, I don't know how this got there, but should pollute more and should pollute less. Wow, okay. And pay more taxes. No, what am I saying there? Tax rate is above the marginal. Yes, the polluter should pollute less, should pollute. Oh, this is difficult this afternoon. So if the tax rate is above the marginal abatement cost, so it means I should abate more. So pollute less, yes, and pay more, pay less tax. And yes, if the tax rate is below the marginal abatement cost, polluter should pollute more and pay more tax. All right. So that's the gist of it. So this is our setup. If you pay attention to what I'm doing, I'm always using exactly the same. That's the nice thing about this model is you can just explain everything with it. So it's again our love the MACE is 60 minus 4E. And the factory is if, so let's start from the status quo where the polluter would do whatever it likes. So then it would emit 60 divided by 4, so 15 emission. And oh yeah, we have a fishery again. So so the fishery would have a marginal damage of 2E. So that's our setup. So this is 60 minus 4E. Then this would be okay. So question number 1. What is the optimal tax rate? So we are only the 3 of us, or yeah. Still, we can do it. Yes, you have good eyes. Yes, because it's same number as before. So yeah. So what we want, of course, is MEC equals MD. It's always the same answer. So we're going to get 10 and such that so we get equals 20. So that's so how do we know that this is what's going to happen? Well, again, so imagine, let's prolong this a bit. So imagine that we start at E0, then for the last unit emitted, the marginal abatement cost would have been very low because the polluter just doesn't care at all, and it's super easy to start at least abating 1 unit. But the marginal cost of emitting that unit is the tax. So it's 20. So 20 minus 0. So it makes total sense to start reducing, and the polluter is going to reduce until we get exactly to this point. So if you put to reduce more, say 8, then the abatement cost would be higher than the tax, so the polluter wouldn't abate that much. So yes, what's optimal for the polluter is to choose exactly that. So that was question number 1. Question number 2, how much tax was paid? Of course, if we choose t equals small t equals 20, thank God we have helped the rescue. So please help us answer number 2 there. So I can explain. So we have a tax rate of 20. So the polluter chooses yeah. So the question is how much is the polluter pay for the tax? Yes, thank you. Yeah, I'm happy you're here. Otherwise, we would be in trouble. So yes, it's t times star. So that's, yeah, I can put star. All right. Next question. What is the total damage for gun? Or how much damage was avoided thanks to the tax? So of course, if we from the starting point of no abatement whatsoever, so here, so maybe I can put letters that's easier. At least we start with something. Let's say have A. So starting from no abatement to the optimal abatement star, how much damage was abated or was reduced? Yeah. CNB. So almost. That's going to be something interesting. Yeah, and exactly. So what is the total damage for gun? It's so you look at, so you ask yourself, so do I care about the abatement cost or the damage? Of course, now it's the damage curve. So it's the area under the damage curve. So it's 8 so that's equal to 20 plus yeah, so what would be that amount there? 30 maybe? Yeah, I think that's 20 plus 30 times 5 divided by 2. So that would be 50 times 5, 125. No, it's more than that. 5 times 50, how much? Anyways, that's something. Okay, 4. What is the total abatement cost? Ah, okay, good. Yeah, I think that's, yeah, exactly. Total abatement cost. So if you care about abatement cost, then you know you have to care about the blue line here, which is marginal abatement cost. Yes. 200. Oh, I would find this surprising. 100. We're getting there. You're warmer. So the total abatement cost, what is it? So it's it's the area under the marginal abatement cost. So if it's total, then it's the area under something. So we started here with no abatement whatsoever, and now we abated until 10 here. So exactly. So that's 5 times 20. Oh yeah, 5 times 20 divided by 200. No. 5 times 20, 10 times 5 times 20, it's gee, how can I not be able to compute this? It's super easy. So it's like, yeah, it's divided by 2. That's yeah, that's 50. All right, that's right. So it's a. Okay. Now let's continue here. What is the net social benefit? So now you have to think, how is the tax changing things or net changing things? You can venture a guess. Yeah, and go with C and D. So that's so I guess that's, yeah, 30 again times 5. Well, I think this is height of 30. Yeah. So that would be like 15 times 5. So that's 175. And so, but now the crucial question is, what do we make of the tax there? So is that a plus or a minus for society? Well, it's a minus for whoever is paying it. So the firm is quite unhappy with having to pay this, but it's a plus for society. The society gets to either pay less taxes on some other stuff or just use that to finance other things. So if we discard any consideration of efficiency or income effect or other things that may come into play, then it's a wash. So the government gets the money, the firm pays it, so it's we don't have to consider it. So it's essentially exactly the same as just some mandate. If the government says it's 10 and you have to do that, then the firm pays this, and the society has less damage, and the net social benefit is B plus C. And here there's just that the firm pays more, and then there's a government who receives stuff. But so this is something we're going to discuss more. Is we have with taxes the nice side benefit of having the money to do other things. So this is called the double dividend of taxes. 7. So what is the, so last question. So what is the total just want to be sure I'm using this. Oh yeah, sorry. Total compliance costs. For the firm. So how much does it cost to comply to the law? Compared to no abatement? Yeah. A bit more. 200 is how much the firm has to pay in tax, and of course, yeah, that's part of it. But then there's this extra cost too. So what does the firm have to pay? Firm has to pay tax, and yeah, exactly. So it's ADE. Equals to so it's TAC plus, so it's total abatement cost, because I have to pay to abate these last units that I don't emit, plus I have to pay for all of the units that I'm going to pay in taxes. Right, so I think that's mostly what it is. Okay. So this is just restating what we've seen. So polluters pay a tax rate T for every unit discharged. Total compliance cost is the sum of the total abatement cost and the total tax bill. So it's TC plus T. And then the polluter minimizes its total compliance cost by reducing the emissions under the tax rate until the tax rate equals the marginal abatement cost. T equals MEC. This is what he does. So if the tax rate is T, then he's going to choose T equals MEC. And then the total compliance cost is total abatement cost plus the total tax bill, so 250. Socially efficient tax. So what is the socially efficient thing to do? Well, it's always the same. So it's to choose a tax rate such that the marginal abatement cost equals the marginal damage. So then we have to essentially choose tax equals the marginal abatement cost when it crosses the marginal damage. Yeah, so we distinguish between private and social costs. So the social cost of compliance are the resources used to meet the target. So it's just the abatement cost. So what we're saying is, as a society, that's what we have to pay to pay to achieve the objective, but we don't care about the tax because that's something that we can use for ourselves. But then the polluters compliance cost then will include the tax. That's what we say. Taxes are transfer payments to the public sector. The revenue may be used in public expenditure or lowering or other taxes. And the neat thing is that other taxes that we pay on income or on goods and services, or value-added taxes, or in Canada, TPS and TPS TVA. So yeah, value-added tax. All of these are distortionary, every one of them, because they discourage people from doing whatever activity is linked to the tax. So if it's taxing emission, then it's good because it discourages polluters from emitting pollution. But if it's income tax or if it's consumption tax, then it's not so good because it discourages people from having an income or consuming. So what's the amount of discouragement? Labor economists mostly think it's not that bad, but yeah, you should always keep this in the back of your mind because so there it's not that bad because taxes are not that high. But imagine that everybody had a flat tax of 75%. Or would we be so motivated to work every day for a 75% flat tax? Yes. Yes, we try to avoid as much as possible. Yeah, of course. So, and if people are very rich, then that's obviously what they're trying to do as much as they can. Yeah, and you might be thinking about this because we are all filling our taxes right now. So yes, and I'm thinking about not paying too much taxes. Although I'm not too personally, I don't feel that bad about paying taxes because in a so I'm pretty sure you feel bad about paying taxes if you have the belief that it's really being wasted. So I'm thinking some of it may be not used as well as possible, but yeah, some of it still is very useful for like, the government to do useful things like fixing roads. So we want to do our part. Yeah, so then going back to what we're saying, so the net social benefits are then the total damage forgone, net of the social compliance cost. So that's yeah, total damage forgone, next net of the social compliance cost, which is just the total abatement cost. Yeah, here it is. Social cost of compliance is the yeah, so maybe I use total social cost of compliance in the exam, but I'd rather use total abatement costs because at some point it's just so many different acronyms to call things that are similar. That's something that I find a bit tedious about this class is introducing all these names every time. So yeah, please learn the ones that we use a lot for the exam, like TAC and total damage and tax, big capital T, this sort of thing. But I'll try not to get you with you something that we've just used once and you may not remember. And then I'm like, oh, if you cannot remember what you have to compute, you cannot even show that you know how to compute it. So I'd rather not do that too much. Damage forgone, so that's yeah, of 10, so that's this whole area there. So everything that's under the marginal damage. Yeah, so how about cost effectiveness? Or what do we think about taxes? Well, economists are generally positive about taxes. Taxes are popular among economists because, well, as long as they are set properly, so emission tax satisfies the equilibrium marginal principle. Because all the polluters set the tax equal to their marginal abatement cost. So that's something that's nice. We don't have to know a lot of things about every individual polluter. All we have to know is more or less that in general in the industry, the marginal abatement cost will be equal to the marginal damage to the world. Yeah. Plus, what's especially nice is, as we're going to see, if the marginal damage is relatively constant, then it means that you don't have to know anything about the marginal abatement cost or total abatement cost or whatever. You just know that in the wild, if firms emit some amount of pollution, the cost is this much. So that's the tax, and you can go home. You don't have to. It's very easy to compute. If damages are increasing non-linear, then you have to consider the marginal abatement cost too. And but still, it's very neat in the sense that you're sure that every firm is going to have the same marginal abatement cost. So challenge. So advantages. Certain firms. Challenge. Setting the tax. Yeah, so that's what we see here. So when the marginal abatement costs differ among polluters, which is always, so emission tax is cost effective, even if the regulator knows nothing about each firm's marginal abatement cost. But so we still have to know something more or less about the average marginal abatement cost in the industry. The social compliant costs to achieve the target level of emission are thus minimized. So at least we know that, yeah, it's so whatever we achieve as a result in terms of reduction, we know we have achieved it at the most effective way possible, which is something. Yeah, so emissions and cost effectiveness. So imagine that I have one firm with a high cost of abatement, second one a low cost of abatement. Then by definition, if they pay T, the same tax, then they're going to, so of course, the firm with the lower abatement cost is going to abate more, and the firm with the higher abatement cost is going to abate less. And in total, for the total price I'm going to have paid, then I'm sure that I have got the most abatement I could ever want to guess. Now, is this tax optimal? I'm not sure, but at least it's I know it's efficient. Consequences of using emission taxes. So there are many positive effects. One of it is the incentive to innovate. So the emission taxes provide strong incentive to innovate in new technologies with lower marginal abatement cost. More incentive than generally than mandates provide. We're going to see how. So yeah, under the tax approach, so polluters must pay for emission taxes as well as abatement costs. While with standard, they only pay for abatement costs. So the fact that they pay for taxes as well is a very good motivation. Every time some person has a tax to pay, they have a good motivation to not pay it. So Yeah, potential cost savings for new pollution technique are much larger under the tax program. So research and development will lead to bigger reduction in pollution control related costs. So let's go back to here. So how can we see what is going to be the incentive of, so imagine that there's the firm has this abatement cost, but yeah, so firm has this one. What is the and the taxes what is the benefit of investing in a new technology to have. That's not super easy, but I let you think about it. Yeah, and let me even add more letters. Let's add here and so in a sense, what I'm asking is if the firm has MAC1 and had the possibility to have a MAC2 rather than MAC1. So under MAC2, what would be the savings for the firm? Yes? Jesus, you're able to do this. So what letters is it? Not quite, not quite. Not quite. Yeah, D is one, but there's another one. Yes, awesome. So the two savings are A plus D. So how do we see this? Well, we compare the total compliance costs in every case. So the initial total compliance cost, as we said, it's paying the tax plus paying the abatement cost. So this whole region there. And then under the new technology, what is the total compliance cost? So it's the fact that so you would choose 7 rather than 11. So the tax paid is not ECD, it's just E. And then, but then you have to abate more units, but these units don't cost as much to abate. So that the total compliance cost is this region there. All right, so you have first of all, the first units are less expensive to abate, so you pay just B rather than A plus B. And then on this side, it's rather than paying a tax, so rather than paying C plus D, you choose to abate, so you have to pay C in total abatement cost, but you save D in taxes. So that gives you these two things that are going on that makes it more effective for you or less costly to abate emissions. And then that's one. Imagine that the firm has and there is a mandate to emit not more than equals 11. Then same question, what is the incentive to so now compare that to a mandate. So if the firm has MAC1 and there's a mandate to not emit more than E equals 11, so here, and so under that that policy, what would under that policy, what would be the savings for the firm to change to MAC2? Remember, under a mandate as firm, you don't pay taxes at all. The only compliance cost is the abatement cost. Plus, you have a mandate, so no matter what, you have to always emit the same amount. Yeah. Yeah, exactly. It's just a. Why? Because so you always emit the same amount and pay no tax. So under the old technology, you have this total abatement cost to pay. And under the new technology, you have this total abatement. Oops. Have just this total abatement cost. So to answer this question, yeah, now that's getting crowded. Anyways, I do all the computation later. So here, the only saving is abatement cost. So that's really not all that impressive for a firm. You may as well stick with the old technology. You don't save a lot. Whereas for a tax, you know that you can choose efficiently the emission level, and you can so you can save on emissions and you can save on taxes as well. So much more much more profitable for a firm. Now, does that mean that the government should change its keep its tax? So imagine that we're back to this situation and the tax was 16. So does that mean that the government should not change the tax? No, that's a bit the same as before. So imagine that the damage was, so the tax was 16 and it crossed the marginal abatement cost here. So probably we had a situation a bit like this. And now the firm, for whatever reason, chose to reduce its so change its technology, and now it's going to choose to emit here. Well, is that efficient situation? Well, no. In that case, the government is taxing too much. Because here, what you're seeing is that the marginal abatement cost is quite high, but the marginal damage is quite low. So the tax should be lower, should be made about this way. So again, there's a interplay between the government and in the first, but this has all to do with the fact that the marginal damage is not constant. If the marginal damage was constant at say 16, if the marginal damage curve was like this, so every unit of emission always has a cost of fixed 16, then you don't have anything to think about. If you know that, you set the tax to 16 and you're done. You're good to go, right? So yeah, I'm not going to put more stuff on this this graph. Okay, so yeah, this is just to show really how these things work. So the research and development effort would lead to a bigger reduction in pollution control related cost. Because as you see now, we reduce from 11 to 7. Abatement cost plus tax payments will be reduced under a policy of emission taxes that then under a standard approach. All good with this. I went a bit fast, but yeah, I'll show what happens again. So this is it. So the challenge now is to show how computing this is as easy as this formula there. So let's do that. So notes and computation. That's why I was super impressed that you could compute it right away, because it's you have to think a bit about it. So A is what is, so let's start. It's like this big triangle there minus this small triangle here, right? So is it's yeah 16 times 5 times 4 divided by 2. So that's minus this small triangle, 8 times 4 divided by 2. So that's equal to 16 minus 8. So this region there times 4 divided by 2. So it's equal to 8 times 4 divided by 2. So that's a neat trick to know, is even if your triangle is totally slanted, what it's saying there is if the triangle was looking like this, then you know that it's just base times height divided by 2. But it turns out that even if the top of the triangle is totally offside, it doesn't matter. It's always base times height divided by 2. That's a neat trick to compute it. And then what is the area of that one? Then it's again the same base, 16 minus 8 equals 8 times 11 minus 7 divided by 2. So this, we had the base times the height divided by 2, and here we had the base times the height divided by 2. So in a sense, what we need is just the base times 15 minus 7, and that gives you 16 minus 8, this thing there, times 15 minus 7 divided by 2 equals 32. So this is how you get the whole A plus. So 8 so just to make sure that we understand, so this is so we have 8 times 11 minus 7 plus 8 times 15 minus 11. So it's just 15 15 minus 11 plus 11 divided by 2. So that's how I got it. But so if you don't remember that, just use these deductions. You'll get it at the exam. I'm also planning, yeah, to have some computation, but also using just these zones is quite handy because at the end, as I don't care all that much about geometry, so yeah, for you'll have to compute one or two things, but maybe I'll just ask zones there. Yeah, all good. Emission taxes and the double dividend. So I've talked about this. So the tax revenue may reduce other taxes such as payroll income, investment, and investment, which are distortionary. Yeah, so the first dividend is the reduction of emissions, and the second dividend is increase in consumption, savings, work effort, investment in the economy due to lower taxes. So that makes taxes very, very efficient. Also, so what information is required? So it requires information on the item to be taxed. Especially, I must be sure that I monitor people. So because if I want to know how much somebody owes me in taxes, then I must be able to know how much that person has emitted this year, for instance. So you need accurate information on this. So it can have distributional impact. So this is impacts on prices, outputs, and goods and services affected by the tax. So what we're saying here is that, yes, we are having some effect on the industry. So if the industry was producing 15, then this is reduced to 10. But of course, that's the same thing as any other policy. Same as mandate, for instance. But then what is not same as mandate is effects stemming from expenditure of government generated by the tax, which is then this is just a bonus. Also, yeah, so here we're getting into really the two best one, the two most popular measures, which are taxes and quotas, but taxes versus standard and quotas. In the presence of uncertainty, so this is more advanced stuff, but it really does matter at the end to decide what is the best policy to implement. Should I implement standards? Should I implement a tax? Should I implement quotas? The problem is, so as we have seen, it's always the same model. If I know exactly what is the marginal abatement cost and the marginal damage, there's absolutely no difference between each of them. So in practice, what makes a difference? What makes a difference is oftentimes the shape of the marginal damage curve and the presence of uncertainty. So especially uncertainty in abatement cost. I don't know exactly how much it costs for firms to abate. And I don't know exactly what is the shape of the marginal damage cost, but I'm going to try and pick the policy that gives me the less risk or the less the smallest deadweight loss if I can. So to get as close as possible to the MAC equals MD. And this depends on, yes, on the shape of the different curves and the shape of the damage. Yeah, so, and as I've said, if the marginal damages are relatively constant, then taxes equal the marginal damage guarantee an efficient outcome regardless of the true marginal abatement cost. So I don't care if it costs a fortune or not. I know that this is the damage that you're causing. So this is the tax and you pay it, and that's very, very efficient. But if the marginal damage is highly nonlinear, then the appropriate tax rate may be difficult to set such that the marginal abatement cost equals the marginal damage. So in that case, a mandate or tradable emission permit would may be more appropriate. So let me show you what I'm saying there. So here what I have is some uncertainty about marginal abatement cost. So imagine, for instance, that I think that the marginal abatement cost is here. Then what should be the optimal tax? Then it should be such that and then I have this really exponential marginal damage. So in that case, the appropriate tax would be like here, for instance. Of course, don't worry, we're going to finish with this. So this has been discussed quite a lot in research. So if I'm thinking this is my marginal damage curve and this is my marginal abatement cost curve, then I'm going to set the tax rate at this level there. For instance, I'm going to guess, TG for guess. Yeah. But then what happens if my marginal abatement cost is not this, but this? So let me have something. So what's going to happen? Yeah, now that's getting a bit more intense. Try to think a bit about it. So what are firms going to do, and what is going to happen in terms of efficiency? Is abatement going to be too low or too high? Okay, start over. This is what the regulator thinks firms have in terms of marginal abatement cost, but there is some uncertainty, and this is the marginal damage. And then what should the regulator do? Well, always the same, set such that marginal abatement cost equals marginal damage. So we get here, and we set a tax this way, TG. So forget about the red curve there. Okay? But then I tell you, in real life, firms have a higher abatement cost than we thought. So they are going to, yes? Yes, exactly. So the regulator thinks that firms are going to pollute up to here and that this is efficient, but up to where are they going to pollute? Well, their true marginal abatement cost is that one. So they're going to pollute until their real marginal abatement cost equals the real tax rate there. And in that case, is there too much abatement or too little abatement? Yeah, exactly. Way, 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 way too little. So because so all of this, so I don't know where this goes, but it's to the moon, maybe. I don't know, but you see that, so all of this is ton and ton and ton and ton of damage that is not abated. Just because I had this small mistake where this is not a huge uncertainty, maybe it's like the cost is like 60% higher than I thought, and that's the result. So in that case, using a tax is awful. It's super imprecise that I should never do that. But then if rather than this exponential marginal damage, I have this constant marginal damage. Well, in that case, well, what is the efficient tax if the marginal abatement cost is the black one, which I think it is. Oh, well, I should never erase stuff. Yeah, so in that case, the optimal tax is always marginal abatement cost equals marginal damage. And I'm here. And that's efficient if that's the marginal abatement cost. But then I make a mistake again, and the marginal abatement cost is much larger. What are firms going to do? Well, they're going to abate until here. But then is that efficient? Yeah, it's also perfectly efficient. Because in that case, you see that I'm still at the place where marginal damage equals marginal abatement cost. So if the damage is constant regardless of the amount of emission, then it's much more efficient. It's very efficient to use a tax, or not rather, it's not efficient, but it's safe to do. I'm quite sure I'm going to get the right answer. Exponential marginal damage. Does that ring a bell to you? Which situation would that look like? We talked a bit about it in the past. But I have something precise in mind. Well, many situations. Yeah. Yeah, no. What I'm saying is what situation, what concrete pollution situation may show up as exponential marginal damage like this. Or could, I'm not saying that, I'm sure, but I think this was part of the program for the first midterm. In fact, no idea. It's a situation in which if you are below some crazy number here, then things are under control. Damage is not too high, but then if you go beyond some threshold there, then things are awful. No idea. I have few examples in mind. So that could be, for instance, air pollution, for instance, where if you have a low level, then yeah, people cough a little, but that's not so bad. But here, really bad. Yeah. Yeah. So are you saying you disagree with me or? Yeah, yeah, yeah. Yes, exactly. So it's if you have very little, then it's for most human, it doesn't matter too much. But then at some point, people start like really having a bad time in the industry. Other example is climate change. So we don't know what this curve looks like, but scientists say, yeah, we think that if we're below 1.5 Celsius, we're good. Things are under control. We can more or less predict what's going to happen. 2 degrees, yeah, not too sure. 3 degrees, yeah, all hell might break loose. So in this case, is a tax on emissions the right policy? Or, well, if you think that abatement costs are very high, then you should have a very high tax to make sure that. So you should set the tax like here to make sure that we stay on this side. But if yeah, more to the point, what we should aim is maybe not a tax, but something like a quota. So if we set some quota that would be like this, and we say, okay, whatever you emit, you cannot emit more than this quantity there, then okay, we know for sure that we stay on the right side of the curve. So this might be like 2.5 degrees Celsius, and this might be like uncharted territory. So at least now we know that with the quota, we stay on the right side of it. So that's way more subtle, this sort of discussion, but that's concretely, it's always a dialogue with economists and climate scientists to know how things are looking. And yeah, this is why, as a world, we might be better off going towards some kind of cap and trade, which we'll discuss in next classes. All right. So yeah, sorry for the chaotic start of the class. So this chapter is, yeah, we still have some stuff to discuss in this chapter, but it's not too